Practice problems here. We talked about the universal gravitational equation found out by Isaac Newton, which is the force due to gravity. Ooh, let me get my pen out. The force due to gravity is equal to big G, the universal gravitational constant, times the first mass, times the second mass, divided by the distance between them squared. Let's go. Okay, so this right here is the formula that we're going to be working on. This is a constant. It's given to you. 6.67 times 10 to the negative 11. That's scientific notation, y'all. So let's do this. I have a practice problem here. If you look to the right of my screen, what's the gravitational force between two identical 50,000 kilogram spheres that are separated by a distance of 1,000 meters? So the distance is 1,000 meters, and the masses of each of these, the masses are the same, they're identical. That's 50,000 kilos. 50,000. That's pretty heavy. That's pretty massive. 50,000 kilos. So the question is, what is the strength of the gravity between these two objects, right? These asteroids, as it were, in the problem. Well, to find out the force of gravity, all I have to do is input what I have in the problem and solve, right? I have, the first thing is big G. So the first thing I'm going to do is, in parentheses, I'm going to put my constant. It's never going to be different. It's always going to be in the problem, and it's always going to be 6.67 times 10 to the negative 11, right? And then I'm going to multiply the first mass, which is 50,000, right? 50,000. And then I'm going to multiply the second mass, which is also 50,000. It's not always going to be identical. And then I'm going to divide by the distance squared. So the distance in this case is 1,000. It's 1,000 meters away. And we're going to square that, right? So how do I put this in my calculator? How do I solve that? I'm going to show you my favorite way. If I don't have a TI Inspire, I'm going to hit Mathway, and I am going to type it in exactly as I see it. So parentheses, 6.67 times 10 to the negative 11. But there's a problem. The computer thinks that x, right, when I type in x as times, it thinks it's the variable x. So there's an actual button for scientific notation. It's right here. Can you see it? All I do is hit that, and then it brings up times 10 to the whatever. So now I can put in my constant, 6.67 times 10 to the negative 11. Very, very small number, times 10 to the negative 11. So I'm going to type that in right here. So here I go, 6.67 times 10 to the negative 11, right? And remember, that's what F sub g is equal to, so that force is equal to 6.67 times 10 to the negative 11 times the first mass, which was 50,000, times the second mass, which was 50,000. You know what I'm saying? Here it's just typing in numbers. And I'm going to divide that, and you see I've got my denominator here. And I'm going to still use parentheses because I'm going to make it nice and tidy. It's 1,000 meters apart, and I have to square that, right? I have to square that. Now, you see how it looks exactly like my equation. The force of gravity is equal to the gravitational constant times the first mass times the second mass divided by the distance squared. And I'm going to solve this, right? I'm going to solve this, and it's going to give me an answer, right? And here I have it. What happened here? You got to take out these, commas. Don't like those commas. We don't like those commas, man. So here we have the force is equal to 1.6675 times 10 to the negative 7, right? That's that decimal form. That's that form that I want you to put it in. If you want to put it in this form, that's fine too. This is also a big number, right? That's 7 decimal places before that 0.00000016675. So that would be an acceptable answer. I want you to go ahead and solve the equations using the universal gravitation equation. Use Mathway to calculate and upload your work and get 100. I think that's as easy as pie. Let's do it.